forward, right? So keep that in mind. So the first type is called the profit/revenue types of questions. So they mean the same thing, profit, revenue, right? It's income. Uh, you will need to create a table with the information that you're given. And I guess I just say that types 1 to 3 require you to create a table, and you need to produce at least 3 points to perform the regression. How would you recognize this question, type 1? It's actually fairly simple to recognize because there'll be some kind of dollar amount, right? Trying to make as much money as possible type of scenario. And so look for these keywords here: profit, revenue, items sold. It could be bikes, canoes, chocolate bars, you name it, right? And there's a money amount associated with it. Steps. These are the steps, and I kind of box them in. You would start with creating a table that has 3 columns like that. Keep in mind that just to be clear, these first, the 2 up here, it doesn't matter which one you do first. If you want to do items first and then cost, or cost items, as long as your profit is at the end. So let's say, tickets for a concert, they cost a certain amount per ticket. To get the profit in that scenario, you would just multiply these 2 together, right? So cost times items would generate the profit for that certain scenario. The second step, so once you've created this, we go to our second step, which enter either the cost or the items into L1 and profit into L2. So this is very important that the profit, you got to make sure, right? Profit goes into L2. Right, this is L2. And this could be L1, or L1 could be, you could designate either one of these columns to L1. Okay? And this is how you will know. Note, what goes into L1 depends on the wording of the question. Does it ask for the equation relating the cost and profit, right? In which case you would put this into L1, and then you would put this into L2. And then every point would be cost and profit, right? Total profit, total revenue. Or does the question ask you to come up with the equation relating items and profit? So you would put this into L1, and this goes into your L2. And in that case, once you generate the equation, every single point will tell you that how many items were sold to make a certain profit. Okay. What goes into L1 depends on the wording of the question, and you will see when I do go through the examples, you'll see what I'm talking about. Okay. Question 3, perform the regression using quadratic regression, quadreg, right? Make sure that your resulting equation does not have an a equals to 0. That is very important. I will highlight that whole thing, even though it's already in bold. If you get a equals to 0, you made a mistake. You entered, the most common one is this one. Ready for it? Oh, L1, L2, of course, right? L1, L2. Right? You're going to get a equals to 0. And so your x squared term is going to be non-existent. So then it's actually a linear. It turns into a linear equation. You don't want that. Okay? So make sure you remember that. A little note on this, since L1, L2 are being used, we turn on plot 1, right? Yeah, I would say use Zoom 9 to help you see the graph, right? But you gotta adjust your window until you see the entire parabola. You can use Zoom 9 all you want, but don't stick with it. You need to adjust your window accordingly, because Zoom 9 is just going to zoom into those points that you've just created. But if you're in the thousands, it's nice to get a starting point and then move away from it as needed, right? Generally, questions of this type will ask you to how the profit can be maximized, right? You want to maximize the profit. Okay? This means that you will need to find the vertex, right? Because it's within the vertex where you get the maximum profit. Notice that break even happens at the x-intercepts. So why do I have the two graphs there? I will never make you graph them both, but this is what could happen. Obviously, profit always goes, we always put that in our y-axis, right? So both of them would be having the profit along the y-axis, but it could be that the cost or price, right, is along the x-axis. And remember, you want to label and put the units down. Or it could be if you put the items into L1, then, right, the bottom would be items. And I'll just say, what are my units? Number of, right? Number of items. In both of the cases, right, either you focus on this or you focus on that where you put the number of items into L1. This top number, this is where you get your maximum profit. Like if you scan the y-axis, right, this, right, it coincides with the vertex. So here you would have cost and profit, and in this second graph here you would have items profit. So let me give you an example. Let's say you're trying to find out the best price that you can charge for a certain chocolate bar that you're producing, right? And if you graph that thing, there's a certain point where if you were to charge $5 per bar, you would get the most money because you would sell the most, right? Under this circumstance. If you graphed it like this, where you made the number of items your x, right? Then a certain number of items sold would result in the maximum profit. But the profit in either case will be the same, right? Let's say it's $10,000 profit. It'd be 10,000 under this graph, and it would also be 10,000 under this graph. We're just having different values entered into L1. That's the difference here. But again, we are only going to do one at a time. We're not going to do both. I promise you that. Flip over to this to page 22 here, and let's dive into our first example. Be careful with those staples. Don't get bleeding finger there. Okay. So here's how a classic type 1 scenario works. Okay. So a movie theater charges $1.80 per ticket. That was back in the days, right? It's a bit dated. That's besides the point. At this price, at the $1.80, it sells approximately 400 tickets per day. And here's where the change comes in. Watch this. This is what's going to help you make your table. The theater manager has observed that for every 10 cents increase in ticket price, 40 fewer tickets are sold. So basically, if you're increased by 10 cents, right, your ticket price, you will sell fewer tickets, right? And that should make sense to you, right? The more you charge, if gas goes up, people try to drive less, right? If gas goes down, then it probably will be more the other way. So there's like an inverse relationship. So what we do here in this case, there's of course the profit here, right? And the profit would be in this case tickets times the cost per ticket. That, I would say that's probably a good starting point. And then, so these are my two variables here. So how about we do the cost first? So the cost per ticket, and this is the number of tickets. So this is like the number of items, so to speak. And the profit, of course, would be cost times tickets. And the first line is usually provided by the question. If it's $1.80, you would sell, under these circumstances, you would sell 400 tickets for that particular day. And so it stands to reason that we go 180 times 400 over here. Let's not fill that in just yet. We're just going to do that, write it down. I'll show you how I do it with my calculator later on. Then from here to here, we know that if we increase that by 0.10, right? Sorry about that. It's supposed to say 10 cents there. You go to 190. And if you keep doing that, if you keep adding 10 cents, right, then you get to $2 here. So you keep adding 10 cents, 10 cents. You could keep going, but I usually stop after 3. I need 3 points. So I'm going to have 3 rows. That's all I'm going to do. For every increase, what happens to the number of tickets? They drop by 40, right? So then I have 400 minus 40 is 360. On a subsequent increase in price, you would sell 40 fewer tickets again. So that gets you to 320. Please take your time to fill these in. If you get it wrong even by 1, you get a completely different equation because it's going to try to fit those points, right? So this is provided by the question. Like when something goes up, the other thing goes down, or vice versa, right? So we now go 190 times 360 to get the profit under this price, right? Under that price, you'd be selling 360 tickets, so that would provide you with a profit. Under a price of $2, you'd be selling 320 tickets, and so forth. Now, I want you to think about this. If you charge ridiculously low price, you're going to sell a lot of tickets, but you're not going to make a whole lot of money, right? As you start increasing the price, you're going to make more money, you're going to make more money, but then there's a point where you make a lot of money, the most you can possibly make, and then when you charge too much, you start to make less. Why is that? Fewer tickets are going to be sold, right? Because you're charging too much. So usually this type of question will get a parabola going for you, okay? Determine the equation relating, watch this, what relating what? The ticket price and the profit. That gives it away right there. And I will always be very specific there. That means that I will do the following, right? I will put the ticket price into L1 and I will put my profit into L2. So we need to go stat, calc, quadreg, and we're going to come up with our equation. And we need to do a whole bunch of things before we do that, right? We need to press stat and edit, and watch what I'm going to do here. The ticket price, so the cost per ticket is what goes into L1. So go ahead and type those in. Those you can go ahead and you don't have to go 2.00. It will get rid of the zeros anyways. And watch this, L2, you actually read this out like as we wrote it down. So 1.8 times 400, you can actually type that in like that. When you hit enter, it automatically fills in, right? It's like an Excel spreadsheet. It goes 720. Then it's 1.9 times 360, hit enter. Then it's 2 times 320, hit enter. And then that's when I go ahead and write in these numbers. It's just faster overall. So this is the resulting profit, right? So these technically all have dollar amounts in front of them. So I've entered the ticket price into L1 and I've entered the profit into L2. Now I can go ahead and perform the regression. So I press stat, calculate, I go to quad reg, and then I'm going to go second 1, comma, second 2, comma, vars, y vars, enter, enter, enter. And I will make sure that A is not 0, right? So that's good. C is 0, I don't care about that, but A cannot be 0. So my quadratic equation will be negative 400 x squared plus 1120 x. Okay. So that is my quadratic equation. And I will emphasize that every single point on that equation will price profit. And I tend to give profit a capital P there, right? Price profit. And there we have it. Okay. So you're like, what is that graph doing there? It's just to give us a bit of a visual. So this would be the price in dollars in this case. And this would be our profit. And we will fill this in as we go along. Okay. So it's just price down here, profit there. That's what we're focusing on. We don't have the number of items on this graph. I'll show you how to get that in a bit. Okay. What ticket price, read carefully, what ticket price would result in the maximum profit? You want the maximum profit. And what is the maximum profit? So what ticket price and what is the maximum profit? Find the vertex, okay? By the way, if your parabola goes upwards, like if it's pointing up, you probably made a mistake, right? With profit, it shouldn't do that. And so we're going to go second, trace, and what are we going to use, min or max? We're going to use max, right? Hopefully that makes sense. But that requires us to actually find an appropriate window. Okay, so what do we do? Well, zoom 9 only works if plot 1 is turned on. So I'm going to go check, and plot 1 is indeed turned on. I'm going to clear whatever is in Y2 because that's from a previous question. I don't want that. And now I'm going to press zoom 9. Like as soon as everything is cleared here, I'm going to go zoom 9. And it looks like a straight line almost. So don't think that that's your graph. Now we need to go to our window. And I'm going to go X min. I want to see a little bit of the negative on the left side. So I'm going to go -2 or something like that. X max. I want to see a little bit more to the right, so I'm going to go 5. Let's see if that works for me. And this is where we have a bit, Y min, you want to see your x-axis. And I'm going to go a little bit below the x-axis. So I'm going to go minus, I think 150 will do. And Y max, I have a pretty good feeling that I wasn't seeing my vertex yet, so I'm going to go a little bit higher. Let's say 1,000 there. Let's see if that does the trick. So as you can tell, it's not an exact science, it's just see what works, right? And then hit graph. And there I see, so what you were zooming in on earlier was just these 3 points that we've created. And then I moved my X min, I moved my Y min, I also moved my Y max and my X max, right? So now I can see everything in the first quadrant. So let's go ahead and find our vertex. So you go to the left of it, hit enter. You go over to the right of the vertex, hit enter, and enter again. And this is what I get, 1.40784. Sometimes the rare circumstances, this point that you just found happens to be in the chart, but it doesn't happen very often. Okay, I would say 99% of the time you're going to have to do this. So what did we just find? This is the ticket price. This is the ticket price. This is the profit, right? So a ticket price of $1.40 would result in the maximum profit or revenue of $784. You kind of just answered everything in this statement right here. So the vertex tells you two things in this case: the ticket price that would result in the maximum profit, and what the actual profit would have been, which is $784. So actually, if you think about it, if you look at your chart, we started at $180, $190, $2, but it actually found, right, we had to go back and actually charge a lot less to actually get that maximum profit. This is just economics 101, right? You learn the relationship between charging a certain price and the number of sales. And companies spend millions finding that sweet spot. Apple spends millions trying to find that sweet spot. Like, what price can we charge to get the most, right? Sell the most. That's what they want to find. So I don't know if they do this kind of stuff, but they do spend a lot of money on figuring out that sweet spot. Okay. D, how many tickets are expected to be sold at the price in C? How many tickets? Right? And this is where you use profit is equal to price per ticket, right, times the number of tickets. That's where I want to use the formula. I want you to use the formula because you don't have, you didn't focus on the number of tickets. But what was the profit again that would result in the maximum? 784. The price per ticket was $1.40, and tickets is unknown to us. What do I need to do there? Divide both sides by $1.40 because you want to isolate number of tickets. That's like X, the variable X there. So do this, and then you say that tickets 784 divided by 140. That's exactly 560. If it's not exactly, you have to round. Okay, so write down the decimal and then go approximately, round it up or down according to, so 560 tickets expected. So I use that formula right? Like if you think about this one, I gave it to you way at the beginning, right? Profit is always found by multiplying these two. So if you have the profit and the price, substitute that in, then divide by whatever is in front of your variable and you get the 560. Okay. Yeah. So let's summarize what we just did here. To achieve the max revenue of $784, right? They should charge $1.40. Sorry, they should charge $1.40 and sell 560 tickets. That's basically in a nutshell what we've just determined here by doing all of this. So we found that line and that table we've created that would give you the maximum profit. And let me just go up to our graph here. And let's just label this 140, 784. This point right here, sorry, I'm going to see if I'm going to ask you to find it. I'm not sure if I asked you to. I will in a bit, so let's just leave it at that, just the vertex up there. E, what ticket price or what ticket prices would give / yield, notice that it's the same thing, yielding or giving something, right? A profit of 450 bucks. Explain why there are two possible prices. Okay, so basically they're saying what price would give a profit of $450, right? So your X is unknown. So what we need to do there is make Y2 equal to 450 and then go second trace 5. Yeah. So let's go to our graph, our Y equals, make Y2 equal to 450 because that's the profit, hit graph. You should do the same, right? And you can tell that it happens in two instances, right? Any price other than the maximum profit, anything below it, there will be two instances where that happens, right? So I will say this, point 1, right? First point, let's find that. Second trace 5. I'm going to go to the left, hit enter, 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 and that gives me 0.49. 450. And then point 2, which is on the other side, second trace 5. I'm going to skip to the horizontal line and hit enter, enter, enter. That is 231, 450. You can't see that. There it is. So there are two instances. Charging 49 cents or 231, right, per ticket will give a profit of 450. charging 49 cents or $2.31 will give a profit of 450. And this is my explanation. That's the best you're gonna get in this little space here. Okay, lower ticket price, right? What will that be? More sales, more ticket sales. Higher ticket price, fewer sales. Both result in same profit. So as an owner, I don't know. I think I would rather charge a little bit more so that I don't know, if you're thinking of a movie theater, the more people walk in and out, the more people use the bathroom, the more people, it's going to be harder to clean, right? So you might say, yeah, I'd rather charge a little bit more and not have as many people come in. It's up to you, right? Like you choose what you want to do there. Or if you want to make it affordable and accessible, you charge less because you make the same amount. You're just going to have more people rolling in the store or the theater in this case. So that's why you have two instances there. There's like a give and take. One goes up, the other one goes down, right? All right, let's do some graphing here. And this will require us to find, right, find intercepts and vertex, right? That's basically what I'm going to tell you. Find the intercepts and find the vertex. And we already know the vertex, right? The vertex is 140, 784. X-intercept. What's my first x-intercept? It seems like it's 0, 0, right? We will double check and make sure that is the case. And the other one we're going to find in a bit, okay? I know that it's going to be 0, but it's going to be something else there. So let's go ahead and find that. Y2 is equal to 0. And I'm hoping for something to happen at one point, but it hasn't happened yet. And I just want to make sure you don't get it wrong when that shows up. So let's see, maybe this will do it. So y2 is equal to 0. I hit equal graph, sorry. And it's graphed it now. So just to make sure that the first one is actually, I'm going to make sure the first one down here is actually 0, 0. So enter, enter, enter. It is 0, 0. So the first down here is 0, 0. So that you can rest assured now. Then you go over to the other side, find that second x-intercept. That's close enough. Enter, enter, enter. And that's 2.8. 2.80 because it's a dollar amount, right? 2.80. So there you have everything you need to graph this thing. So go ahead, watch this, right? You gotta make sure you don't lose silly marks here. So what do we have here? This is ticket price. And it's in dollars. So if you want to get the full marks, make sure you have that. Here you have your profit. It's also in dollars. Let's see here. 0.51, 1.52, 2.53. So I'm going to go up by 0.5. Okay. So I go up by 0.5. And along the y-axis, I need to make sure 784 fits in. So I'm thinking 800. So 200, 400, 600, 800. That'll be my that's pretty good. 140. Somewhere in here. 140, 784, right about there. 240 is right about there. 0, 0. Was it negative 400 x squared plus 1125? Totally guessing here. Let me see. Oh, almost 1120. There. That's that'll give you the marks. Scale, shape, equation, labels. You're good. Domain and range. When we look at the ticket price, it goes from 0 to 240. And for the range, I'm going from 0 all the way to the highest point, which is 784. Or the domain, if you use squiggly brackets, for X, it's 240 like this. And for your range, you decide how you want to state it. No infinities though, right? Yeah.
Current test, we only need to state one, right?
Yeah. The only reason I would want you to know both is if I give you this, it's like, hey, is this the right domain for this graph? You should be able to read it and know if it's the right one. Yeah. Other than that, I will always give you the option to state it in whichever form you want. Because that is what grade 12, they just want you to be able to state it in either one the correct way. No mix math, right? Like some students mix some squiggly brackets in with interval and it's just not pretty. Right? And here's where I give it a twist just for you to know that it could be done the other way. So I'm going to leave this up there for a bit. This is where the twist comes in. Look at H here. I know that it would be rare for me to do this, but watch this. Determine the equation. Let's pretend that we're going back in time, but it says determine the equation relating the number of tickets and the profit, because I want you to watch out for that. So that means that this would go into L1 and this goes into L2. And we're going to go stat, calc, quadreg. Except for what needs to change before we do this. Number of tickets goes into L1. I'm going to go back to my table, okay, just for a bit. Let's all go back to our table. And now we're putting this into L1. This is already in L2, correct? Profit is already in L2, so no changes there. So go back, press stat, hit edit, and you will just replace the entries for L1 to this. And now let's perform another regression. So stat, calc, 5, I couldn't do that cheat because I did a bunch of other stuff, right? I'm sure somebody in here is like, no, I know still how to do it, Mr. Direction. It's like, okay, good for you. Y1, sorry, vars, y vars, enter, enter, enter. There is that equation, and it looks different, right? The values are different, you can tell. So let's go and write that down. Y is equal to -0. I'm going to use all decimals because it ends, right? So it's not, it shouldn't be too much work to do that. It looks completely different, and that's normal, that's okay. It's comparing tickets with profit. That's what it's doing there. Every single point under this equation represents the number of tickets and the resulting profit. It's a bit of a trick question, but not really. What is the maximum profit? Do we already know what the maximum profit is? 784. Let's just double check and make sure I need you to believe me, not just take my word for it. Let's go ahead and graph this and try to find the vertex. So again, if you hit graph like now, try it. Do you see anything? Not much. No. So how are we going to get out of that? We're going to go zoom 9. Zoom 9 to get me started, okay? And it looks like it's a straight line, but it curves a little bit. You should see a little bit of a curve going on. So we're going to go window. I'm going to reduce my X-min and Y-min. Let's just do that for now. X-min, I'm going to go -5. Y-min, I'm going to go -150 because that's always the one that gets blocked when you're trying to find stuff. And I'm going to hit graph. Right, so now I've taken care, I see the y-axis and I see the x-axis, so that's good. Now I need to increase the x-max a little bit and the y-max. X-max, I'm going to go 1,000. Okay, because I can totally see that it has to be at least double and then a little some more. And this I'm going to go 1,000 too, why not? Based on what I saw there, right? And there is your, oh, so close. 1,500 X max. And there's my graph. Perfect. So as you can tell, you had to change your window to make this curve appear. Let's find our vertex. Second trace 4 for max. And watch that. See that? So the profit is 784. And didn't we already know that we would sell 560 tickets? Yes, we did know that. So second trace max, we get 560, 784. We already knew this, right? Max profit, 784, right? Selling 560 tickets. Done. Okay. And we have, on this graph, this is just to give you a visual. This is tickets. This is profit. This is the vertex we just found. X-intercept will be different because you're finding the number of tickets that you would sell at that point. I don't know if I talked about this, but that's the break-even point. If you sell this many tickets, you would profit 0, so you wouldn't really make anything. Same, obviously, if you sell 0 tickets, you'd not make anything. But this is like the number of tickets here would give you. Let's find that x-intercept. What is this here? Right, y2 is equal to 0. Second, trace 5. Let's find that guy. Hit graph, second trace 5. I'm just going to go over to that side. 11, 1,120, 0, right? So this is the break even. That's the break even point, the x-intercepts. I did put that down in our notes at the beginning. We call it like the break even point. Didn't make money, didn't lose money. Kind of not a good scenario to be in though. It's better than losing. But there it is. Right? So the profit doesn't change. What changes is, right, that the first number represents the number of tickets everywhere. Okay. So just watch for the wording there. And there's your homework. You don't even need to write it down. You just, I think 12 to 17 is going back a little bit. Let me just check the workbook here. I think I already assigned 12 and on. Yeah. So 12 is type 0. 12 to 13. So I would say I'm going to post 14 to 17. Okay. We'll post 14 to 17. Okay. If I find the other key, anything in between, I will do that as well. But this is, it's all basically the same type, the same way. I think what I will do tomorrow is I will AC you on a type 0 question and on a type 1 question. Okay, so those are the ones you can expect to try tomorrow. And so I'm leaving you with half an hour to start working on your homework. It is important that you start it today, because if you get it started, you're more likely to do it later on. Okay, so don't let your phones distract you, right? Like, make sure you stay on task. If you need any help, I'm always here.